All right, what is up, guys? This is Ivan again from Brainy-Bits.com, and today in this tutorial we're going to finish this actual tutorial series. This is going to be our final part on controlling a stepper motor using the Rotary Encoder. And what we're going to add today to finish up, we're going to add buttons, tact switches here, and a buzzer. So basically what we're going to do with these is that when I click and hold, this is going to be the in point and this is going to be the out point. So when I click and hold one of these, the buzzer will sound a beep saying that we just set the in point. And when I click this one, it's going to set the out point. So when I just click fast, like just a little click like this, then the motor will move to that in point that we set. And when I click the out point, it will move to the out point. The code is going to seem fairly long, but we're just adding to what we've done so far in part 1, 2, and 3. And if you're just joining us for this part right here, I encourage you guys to go check our other videos so you can start from the beginning and we build up on the code from there on. One more thing also, I always encourage you guys to go check out our website, Brainy-Bits.com/tutorials. And there you'll find a page that is dedicated to all these tutorials. So you'll find the schematics, how everything is connected right here, and the actual code that you can copy and paste inside your Arduino IDE software also. So as always, what we're going to do, we're going to cut here. We're going to go look at the code. I'm not going to explain all the code. If you want an explanation of all the code, like I said at the beginning, just go and check out our other tutorials and you'll be able to follow along where we went from the code and finish up in this code here. So what I'm going to do, I'm going to explain this little part of adding buttons and the buzzer and moving the stepper motor from the in and out points. So let's cut here, let's go look at the code, and then we'll come back and see what happens right here. So let's go take a look. All right, guys, so here we are in the code. The way we're going to do this today, I'm just going to outline the changes that were made for this part 4, this final part of this tutorial series. Now I encourage you to go back to part 1, and then you'll see how we developed this code. And part 2, we added some more, and part 3 also. And this would be the conclusion. So what I'm going to go through today is actually the parts that, in regards to the tact switches, and the buzzer, and the moving of the motor when we click either one of these tact switches. So the beginning is all the same, so I made some more space here so I can see which part have been added since our last tutorial. So we're going to go all the way down here. So in and out switches connection. So these are the pins that the switches are connected to. And also I encourage you to go to Brainy-Bits.com/tutorials to see all the connections. The schematic is there so you can see more clearly how everything is connected. So we're defining switch pin in, which is going to be used for the in point. It's connected to A0 on the Uno. And switch pin out, which is the out point switch, is connected to A1. Next we have the buzzer connection. That is connected to defined buzz underscore pin. It's connected to A2 on the Uno. So now we're going to go down. This is not new, so we're going to go down a little bit more. This is not there, that's fine. And here is the next one that we added. We created 2 variables. One is called in position and out position. This will store the in and out point stepper position in those variables. We're setting it at 0 at the beginning. And then we do a time variable that will be used to detect long presses of the tact switches. So then the interrupt is all the same, so that is nothing new here. Now in the setup, we need to actually initialize all these pins. So we do pin mode, buzz pin is an output. We write the buzz pin to low, meaning when we bring it to high, then the buzzer will sound. And we do the same for all the other pins here that we just created. All this is all the same. We didn't change anything here. So we're going to the loop of our code, and that's where at the beginning we are looking at these switches. So if the digital read of switch pin in is equal to low, then we're going to do this thing here. So we put millis into the variable time. Millis is a function that actually keeps counting when you start your Arduino. So basically what we do is that we put the value of millis right now into time so we can compare it at a later time to see if enough time has elapsed to actually detect a long press of a button. Then we do the delay of 500 just to debounce the switch. And then that's where we check if the switch is pressed for longer than 1 second. Actually, it should be, yeah, it is 1 second, sorry. So if digital read switch pin in is equal to low, meaning it is pressed in, and time minus millis is greater than 5,000, that means that we've been holding the actual button. So then, that's true, we're holding it. So then we do a digital write of the buzz pin high, meaning we sound the buzzer, a little delay of 100 millisecond, and then we switch it off. So it'll just do a small, very short buzz. And then we set the in position is equal to the stepper position. So meaning we set the in point because we were holding down the button. Now, if it is a short press, then what we're going to do, we're going to see first of all if the stepper position is equal to the in position, meaning it's already at the end point. If it is, then we don't want to move the motor for no reason. So we're not going to do this. But if it is not equal to the in position, then we check if the stepper position is greater than the in position. If it is, then while the stepper position is greater than in position, we're going to move the motor. Like we did in, I think in tutorial 2, we did this part. So we do a for loop and move the motor, and then we decrease the stepper position minus steps to take. Steps to take is the speed of the motor that we set at the beginning. And then we do a little delay, and we do 100 minus steps to take time 11. And that is to set the speed of the motor. Because if the steps to take is at, let's say, 8, so 8 times 11 is 88, so the delay would be 22. But if it is set, let's say, to 9, then 9 times 11 would be 99, so the delay would be 1, so it would be faster. So that's the way we set the speed at which we move the motor when we press the in or out buttons. So, you know, it seems a little bit confusing, but if you go line by line, you know, you take your time and then you'll see what's happening in here. So basically all that's happening, if we detect it's a long press, that means we set the in position, we don't move the motor. And if it is a short press, then we move the motor until the in position is equal to the stepper position. And else, while the position is smaller than in position, depending on where the motor is, we want to move it counterclockwise or clockwise, so that's how we check. And we do the same thing here, basically. And then this other part is for the out button. It's exactly the same thing, except the variables are changing. So if we do a short press, it will move the motor. If we do a long press, we store the position of the stepper into the out position variable. And basically that's all this does. It looks like a lot of code. It could probably be simplified, of course. But the way we've written it, it's kind of easier to see what's happening. But you could put all this stuff in interrupts too and call it up when we press the button. We just wanted to make it simple so you guys can go line by line and actually see what's happening. And that's all we added. The rest of the stuff was there from our other tutorials. So that's it. So that's how we're actually doing long presses, short presses, and moving the motors from in and out points. So we're going to upload this code to the Uno, and let's go back and test it out. All right, so we're back, and we uploaded the code that we were looking at on the Uno, and the Uno is powered up. And we powered up the easy driver, motor driver also. So everything is set up. So we'll see the motor here. We'll see the speed that it is set at. And we have our in and out tact switches here. So first thing we're going to do, we'll leave it at slow speed. And we're going to set the motor, let's say the in point is going to be around right here, like this. So I'm going to click and hold. And there we go. We heard the beep. So that our in point is set. Now I'm going to move in the opposite direction, 180 degrees, let's say, so it's easier to see, like this. And I'm going to set the out point, press and hold. And there we go. Heard the beep again. So now I'm not going to touch anything here. I'm just going to move from one point to another. Now, keeping in mind, this is the slowest speed, so it's going to go fairly slow. So I'm going to click once, and there it goes. So it should do a rotation until it hits the in point right here. And there we go. We're back to the in point, and now the out point.
Just click quick on the tact switch, and it goes back to the out point. Now once it reaches there, we're going to change the speed. So we're going to change the speed now to, let's say, all the way up. There we go, all the way up. Click to set. Now let's say I'm going to set an endpoint right here, in. And there we go, endpoint set. And I'm going to put the other one, let's say, right there. So click and hold. And there we go. So not touching anything. I'm going to go back to the endpoint. There we go, a lot faster this time, and the out point. And there you go, seems to work pretty good. So there you go, guys. This concludes our tutorial series on controlling a stepper motor using a rotary encoder and setting the speed of the motor, and also using tact switches to set in and out points. Now, this could be used for multiple things. You could use this little part here of the the button presses. You could use the LED part to use in a project, the rotary encoder part. And actually, this setup, could be modified to make some sort of follow focus for a camera. Basically, the motor would control the focus on your camera, and using the in and out points, you could set those and the speed also. So anyway, I mean, you guys can take parts of these projects and actually make it your own. So that's it for today, guys. I hope you enjoyed this series. We're going to try to do more of these in the coming months, but keep a lookout for our new tutorial that should be coming in probably next week, or if not, the week after that. It's always 1 or 2 weeks, depending on how busy we are at that time. So I hope you guys bear with us. We're trying to do the best we can. But we have a store that we actually sell all these parts also, so we need to take care of that. And I encourage you to come and take a look at our store, where you can pick up all these parts at Brainy-Bits.com. And you go in the store section and you can buy all these parts from us and encourage us. So once again, guys, my name is Ivan, and I hope to catch you guys real soon. Take care.